My name is Nick Smith. I'm the Director of Corporate Partnerships at SME, and I have the pleasure of introducing our next speaker, Dr. Carrie Bauer. Dr. Bauer is the Manager of Applications Development Polymer at EOS. Carrie and his team work directly with customers to enable new applications, providing custom consulting and training programs to transform their product portfolio through additive manufacturing. Carrie's presentation today will be on integrating AM with Additive Minds. Without further ado, Dr. Carrie.
Hello, everyone. Thank you for coming to this talk. So what I'm going to be speaking about today is at EOS, our Additive Minds group, which is engineering and consulting group. So we work with our customers to develop applications and consulting packages for them to help integrate our hardware into their product lines to improve their business, to improve their margins and product quality. So first, just a general overview. I think this is probably background for a lot of people, but traditionally, how parts are made currently in a mass manufacturing environment is it's a very subtractive method. So a lot of machine time, a lot of taking a block of material, machining it down, going back and fixing what, the dimensional tolerances, things that aren't right in the first time, and the prototyping phase and the design phase take up a great amount of time, a great amount of money, and that's where we see the biggest advantage of additive manufacturing is it's straight from design file to print. And so not only does this speed up the time of producing a part, it greatly speeds up your time of reproducing a part and improving upon it. And so one of the biggest advantages of our technology is you design a file, you print it, you edit it once you find out that it needs changes, things like that. Well, and traditionally you have to wait for a machine to become available to send the part back and to evaluate it and then remachine it. So really from conception to perfection is where we see our technology advancing others' business cases. And so some other features that we're able to, leverage in our business is we're able to create complex shapes that no one else can. And so imagine a part such as what's there on the left. There's so many internal geometries, so many fine turns, sharp angles, things that we can do that you just can't do through machining or casting or anything of that nature. We can customize individual objects. We can build 70, 80 different parts custom for 70 or different 80 people or 70 or 80 different applications in one build. And so in that way, it's really an efficient tool at revitalizing your your supply chain. And so it frees up a lot of machine time, a lot of personnel time and things. And so the design to print and the custom print is where we've seen a lot of success at integrating into product lines and turning profits. Thirdly, reducing part complexity. So this doesn't mean necessarily design complexity, because we do have a lot of parts that are very complex from a design standpoint. But imagine something like on the right there, you have a component that has 32 different components, all put together and attached and assembled, 32 different parts that can be mismanufactured, 32 ways it can go, not fit together, things like that. By designing these in a way to reduce the components, we can effectively reduce the time to production, reduce the complexity, and increase the success ratio of our products. And so kind of what I was talking about is some of the case studies we've done in the past. We've shown that a typical process that takes 7 or 8 machine steps, different stations and subtractive manufacturing steps, we can do in one print. And so and flexible production, so we can do many different parts, like I was mentioning, and our prototyping phase is very fast turnarounds, and we see that as being a major driver for additive manufacturing in the future and currently. So the graph here is kind of an illustration of the adoption of innovation in the marketplace. So if you go look back in the early 1900s and things, when a product is introduced onto the market, the adoption of consumers used to be a lot slower. So things were taking longer to catch on. There's no social media. There's no, tight-knit trends and things like that. But these days, if you look at smartphones, tablets, things like that, from conception to production to adoption, it's a very quick process. The customer wants the most innovative product that you have, and they want it now. And so we see the ability to produce designs more quickly, validating your designs more quickly, and improving upon them as a major growth factor. And it's in a way that our customers can leverage our products to give them an advantage, a competitive advantage in terms of innovation turnaround. So, and I'm going to talk a little bit more about what our Additive Minds group does, but just to overview AM technology, yes, there's a lot of great technology, not just EOS technology coming on the market, and there's a lot of great things you can do. But one of the most important things, and one of, I think, the things that's not being done in a lot of cases, is transforming our people to know how to leverage this technology. And so what EOS doesn't want to be is just a machine and material producer and just selling our products and never hearing from our customers. We want to help transform the people of our customer base. We want to be involved in figuring out how, what parts can we leverage in your current product portfolio, what can we improve upon with our capabilities, how do we teach your people to think in a way of being able to utilize this technology, and how can we grow along with you to steer our own technology for our customers. And so that is really why we developed this Additive Minds group, in which I am the manager for our polymer Additive Minds. It's a consulting / engineering group that we develop applications directly with our customers, and we teach them how to use our machines on a more detailed and more advanced level. And we also have tools that we can help integrate in terms of part screening, selection, and looking at your business model and leveraging our products to improve upon your business. And so there's really, breaking it down, there's kind of 3 stages of customers right now. We see a lot of the initial customers that don't have a lot of experience in additive manufacturing. And so how we really kind of get involved with them on an early stage is we build benchmark parts with them. We help them to kind of tweak their designs, their material, or their products, and we show the viability of our technology, and we train them on how to do this themselves. Another goal that we have right now is not to just be short-term suppliers, but building partnerships. And so we're a very customer-facing and customer-focused company that we're looking for long-term partnerships to how do we build sustainable relationships to drive our technology forward in a global sense. And I'm talking in terms of all additive manufacturing. I think it's something that we all need to be open on working together where we can, and building partnerships and building products and businesses together. And so we're also, with select customers, building innovation centers where we're setting up 5 to 10 machines, and we're on site with our customers and partners, and then we're using those to rapidly revitalize their business and transform their business to move into the advanced additive manufacturing phase. And so just kind of an overview of what we do. We're a consulting team designed to help your organization transform, and it's really about us not being a supplier. It's about us being a solution provider and a partner to our customers and to those that are wanting to leverage our technology, and vice versa. So what I wanted to do is just kind of give a brief overview of each of the areas we operate in, just to kind of give you a better idea of how we engage our customers and the products we offer. So just to talk a little bit about our training portfolio, there's a large range of kind of general to advanced training products that we offer. Innovation with 3D printing is a module that we offer to beginning customers on what is 3D printing, what are the advantages, what's the kind of way that we can utilize it in your business. Then we offer a design for additive manufacturing course, which this is getting a little bit deeper into, okay, what are the allowables of designing an additive manufactured part? What can you do? What can't you do? And how do you design it for your specific application? So in this module, we would take a specific part file from our customer, spend a couple days with them, and redesign it with them and show them how we can optimize it for their application. We have other consulting or training packages such as topology optimization, exposure editing. So a lot of our customers want to design their own materials and their own products. And so we teach our customers how to leverage our machines with their own products if that's what they want to do. And so we really are trying to offer a diverse portfolio of trainings targeted at all levels of users and helping to kind of grow our customers with us through this training process from basic to advanced. So I just wanted to go into a couple of our more, I guess, popular trainings that we offer. Innovation with 3D printing. So this really looks at two main areas, the complexity and the flexibility of additive, and how do we balance that out in our product portfolio. So looking at where complex geometries, customization, functional integration all collide to give you to allow us to design a product that can't be produced any other way and can help replace or improve current products. The other way is looking at the flexible production time, location, and volume. I mean, often we find that especially our heavier manufacturing customers have one large plant in one area, and it really makes it difficult to diversify their supply chain, but also to kind of diversify the way they make parts. And so one of the advantages that we see is it's a machine, it has some equipment with it, but if you have a room large enough, you can put this machine there, and we can work with you to create these sites around the globe or at your locations to do this. And so the flexibility of your supply chain goes up greatly, and you reduce a lot of that risk of having just one large supply or production site and things like that. And so generally how our trainings are conducted is we lead small groups custom to the needs of your people, and we do it on site at your facility or at our facility. So it's really very customized to the needs of our customers. And so if there's a machine installed at our customer site, we'll go and do the training there, or we have a showroom in a large center in Texas and Michigan where we host training events that our partners and customers can come in, and we can work with them on bringing them up to speed on how best to use this technology. So learning outcomes of this type basic training is to be able to identify and understand the benefits of AM, became a thought leader within your company. So if you have a large company and you train a core few members from beginning to finish on how to utilize this technology, it can infiltrate the rest of your company, and you can use that to kind of advance your company through our specialized trainings. Maybe it doesn't make sense to train everyone in your company, but if you have a tight group that we can then bring to our site or train on site and make them, bring them up to expert status, we can drive your products that way too. And we find that this is, unleashes creativity and innovation throughout our manufacturing platforms. And so this is a 1 to 3 day course depending on what our customers need, and we offer it with a max of about 10 participants, and this is also in metal and polymer additive. So very different requirements from a design side. One easy example is our metals require support structures, and our polymer technologies don't. So you have a lot more freedom when printing a lasered sinter polymer part. You have a lot more design freedom and a lot more ways that you can pack your parts in a build than you do with a metal machine. And so we'll also leave our customers with all of the material that we bring, so handouts, things like that, but the test parts and the parts that we co-developed while we did this process. And so that's something that we find if we work through the entire process from beginning to production with our customers, they tend to retain that knowledge a lot more if they've been through the whole process. So the second topic I wanted to talk about is our AM design training. So we have a training module specifically designed for how do you design a part for an additive manufacturing technology, whether that's metal or polymer. What do you avoid if in terms of maybe part orientation, for surface roughness, for thermal, kind of warpage and things like that. And so we offer an advanced class on how to design parts and how to orient parts in your systems. And so this really gives you the ability to design your part for its function. So it's a way to give you a tool to design specifically for your application, and teaching your people how to do this on their own. The kind of the outcomes of this are to understand additive manufacturing compared to traditional, learn and apply these technical guidelines. So we first teach the guidelines of how do you, orient a part, how do you design a part, and then we teach and watch our customers do that with us. And so we're doing it throughout the whole way together. This actually offers a big advantage for us too, because when you are interacting on this level in a training or consulting capacity, we're learning a lot too about your business case. We're learning a lot about what you need. And that goes into our next kind of our roadmap for our technology too. And so it's really important, I think, to be interacting with your customers at all levels, at all times, to really drive what we hope is a very customer-faced and customer-focused technology. And so similar, design, it's a bit more advanced, but we'll work with you to design parts such as these. You can see the octopus at our table over there, actually, and kind of ensure that all of the AM design guidelines are understood, and develop additive guidelines for our customers' processes also. And so a lot of these guidelines we develop on site when we're learning with the customer what their products are. So that was a little bit about our advanced training. There's a lot more to talk about there, but I didn't want to go into too much of it. So I want to jump a little bit to what we do in terms of consulting with our customers. And so our consulting group is something I think really sets us apart from other producers and machine and material producers, in that we specifically design our consulting packages around what your needs are. So I'm going to go a little bit into how we teach part screening and selection for these consulting packages, but I just want to point out that we develop these specifically with our customers. And so these aren't really going over kind of pre-made courses that have been the same for years and years. No, it's something that it's our experts in the room with your people for a few days, working on your real problems and working on how to advance your technology. So we find that one of the biggest challenges with dealing with our customers is, okay, they understand our technology, they understand that additive manufacturing is on the rise and all of that, general stuff, but one of the hardest questions to answer is, where do I start with my portfolio? Maybe I'm a manufacturer that makes 500 parts. Hey, we could technically make all 500 of these parts potentially with additive, but how do you really go about, how do you really go about deciding what makes the most sense for your business, at what to put into additive? And so I think a lot of things come into that, and how hard is it to redesign? How effectively can you redesign that? What is the cost estimate with AM? And a lot of those questions can be answered by the way we design our modules, and we work with your people to go through our tools to kind of do those calculations and do that part screening work so that we can together go forward and say, yeah, this makes sense to build, this maybe doesn't, and we'll look at it at a different time. So, I mean, the way we kind of look at this is there's always an added cost to additive, designing new or bringing in new machines, new materials, things like that. It's always kind of a startup cost. And so you're in a little bit of a deficit if you just look at the cost to bring that technology there. But if you break it up into ways that you can leverage that to create net value, you kind of start to see a better picture. So cost reduction through supply chain, kind of freeing up your supply chain, making it more flexible, more agile, things like that. Maintenance of the fewer machines that you'll have compared to a traditional way of producing these things. Time reduction, so again, with the supply chain, prototyping, rapid development of products and new designs, and the additional value, which is, you could see if you look at the life cycle costs. So going back to my slide about innovation is happening at a pace that's much faster than it did a few years ago. And so if you look at, the ability from concept to product to speed that up, that's really results in not only a better product, but also a much faster product and a lot more market potential adoption. And so it's really also business one when you look at it. If you're able to stay ahead of the curve and kind of go from conception to product in a very short time. So when we're looking at part selection, going back to my other example, let's say you have 300 parts and you're looking at what do I want to use this technology for? Does it make sense to bring in maybe a new printer for building this part or something? So the way we like to look at it is there's kind of a quadrant box of does it technically fit within additive technology, and what is the economic fit? So what are my economic advantages of using this technology, and what is the technical fit in terms of can we produce it well, can we produce it consistently, things like that. So to evaluate the technical fit of an application, simply we walk our customers through, does it fit into your current AM system or our current AM systems? Do we have the products that can help redesign and help actually produce these materials and parts on our systems? Are there materials available? Do we have the right solution for you? Does it fulfill AM design rules? So going back to our design training that I was talking about before, a lot of parts, frankly, are very basic parts that don't need additive manufacturing. And so it's also a thing of being smart. We don't think we're going to solve the whole world's manufacturing problems. We don't think that we're going to take 100% of everyone's manufacturing. We want to be in that niche area that drives value for our customers. And so where does it make sense? Where is the product that's so complicated or so time consuming to produce the way we're currently producing it that, hey, additive can really drive down my costs, my time, and things like that. And so looking at that, we take a look at how high are the production costs? What are the savings in the supply chain? What is the value that I really am adding? And deciding a way forward. So is the application suitable for AM, and how can the value be increased? Or how can the production costs be decreased? And so basically, by looking at a quadrant box such as this, you can group your parts into different categories. The higher towards the top right, obviously, that fit an economic fit and a technical fit, then we could say, okay, yeah, it makes sense to print these via additive technologies. And so this is kind of a tool that we like to use when we're looking at new designs and new products that kind of keeps us focused on not just using additive for the sake of using additive, a technology we've heard a lot about and people seem to be adopting it, but how can we sit down and look through our products and methodically think, okay, here's how we can partner with EOS, here's how EOS can partner with you, and kind of use these tools to determine together, does it make sense for your product line to kind of adopt this technology. So during these types of workshops, this is also something we like to hold at our customers' sites or at our own sites. We have training facilities for this, and it's very interactive. We have our specialized consultants for these, either metal, polymer, and design consultants that can, in an interactive way, be brainstorming these with your engineers, with your people to say, okay, yeah, this makes sense. No, it doesn't make sense, and kind of have that interactive discussion that we find leads to a really fruitful kind of result that not only we determine what parts make sense, but we build that knowledge of the methodology of how to do that and how to kind of look at this from I guess you need the points of view, you need our point of view and we need your point of view. And so we're looking at it from a realistic manufacturing view and also from an additive cost and capability viewpoint also. So really the desired learning outcomes of this are to understand the possibilities and limitations of AM. So once we work with your folks to make sure that the technology fundamentals are understood. We look at case studies from the industries, things from our past that we've said, okay, yeah, the part that you're looking at, we've done something before and like this before, and it was, it could have worked out, but the costs weren't right because it took too long for a certain reason, or yeah, we've seen something similar. We can, maybe look through that and work with you to that, to do that. And so, and to teach the part screening methodology. So this is something that we want to walk away knowing that your people have a knowledge of how to do this and how to utilize our kind of our tools that we've developed. And we, of course, are always on hand with our customers to help solve these problems together. And then I think the next step is applying these methodologies to your portfolio and evaluating the design and redesign and integrating into your product line. And so it starts with being able to understand the technology, understand your portfolio and how to drive that forward with EOS technology, and understanding how to redesign specifically for this production method. And so again, kind of still going over the deliverables, we have tools that we give to our customers, cost calculation, screening detail tools, tools that help you understand the kind of the difficulties and the advantages of using this technology. And so last point I want to touch on is innovation centers. Just want to go over a couple that we've set up with our partners. In Germany right now, we've kind of brought them through this process, Audi through this process of introducing the concept of additive, to teaching them how to use additive, consulting with them on what products can they use to customize to make it make sense economically for additive manufacturing. So their objectives that they were coming to us with were they want to move prototyping to industrial application, integrate additive capabilities with tool development and tool making. So really driving customer-focused kind of custom parts. They were looking at production of inserts for die casting molds. And so basically one of their things where they were looking at dashboard components, how can a user maybe wants to put his name on his car dashboard, we can use our tools to produce a die that allows them to customize parts of their dashboard and things like this. And so what our role in this is supplying the equipment process, of course, but teaching them, training them, consulting with them on here's what we can offer, here's how it fits into your portfolio, here's how it doesn't fit into your portfolio, here's the economics of our materials, our machines, upkeep, all of that and drive that together through it. So this is kind of I show this example because it's kind of an ideal example for us of leveraging our Additive Minds team to not just sell a typical customer a machine or a material, but it's a joint learning and a joint partnership to where we've learned a lot from this and they've grown a lot too. And so this is a really fruitful relationship that is continuing to advance both of our business cases as we move forward. And so we've set up this from pre-project, we've set up the teams first enablement. We're now in the factory layout planning and working on customer scope projects, and we're driving this forward together as partners. through our Additive Minds group. So the last kind of slide I have is UDRI also is another partner of ours that we've set up an innovation center with them. And so their goals were really more on building parts that are certified for certain processes. So we went along the same kind of development path of installing our machines, teaching them how to certify our machines, how to do part screening and selection, supplying our machines with them, and all the way through machine installation. And so this is kind of just a summary slide. At Additive Minds, so like I mentioned, we are the consulting and application engineering group in Additive. So we kind of are at the midsection of engineering and customer consulting and partnership building. And so we, along the kind of wheel that I have there on the left, we develop applications, ramp up production with our customers, and we qualify and scale production with them. And so we're very, very much in the mode of developing partnership, customer relationships, and so open to any conversations that anyone has about how to potentially work together or utilize our teams and your teams to work together. So with that, I want to thank you for listening, and thank you for your time.